Hi, my name is Juan Leal A01570711 and welcome to my final project of Calculus 2. Let's start. So the career that I will study at Tec de Monterrey is mechanical engineer. Why? If you like machines and if you like to know how things work and obviously you like physics and math, this is your career. The topic that I discovered that will be used in mechanical engineer are moments of inertia. Moments of inertia is a topic about physics that uses integration, and the integration technique that is used is definite integrals. The area of application of this topic is mechanics. So let me search for an example. Ready, I found an example. So this is an example of moments of inertia. So in this case, they ask us, find the moment of inertia of a uniform thin rod with the axis at the end. And as you can see, you have your axis of rotation, that is your z-axis, and this is your thin rod that has a length of 5 meters, from 0 to 5, and a mass of 0.2 kilograms. But I know it's kind of messy, you know, like it's not as good as a computer or a mathematical software. So let's use one, okay? So 1, 2. Welcome to this 3D representation. We will find our uniform thin rod. As you can see, this represents the rotation that the thin rod will make with the moment of inertia we need to find. The blue axis represents the z-axis that rotates the thin rod. The x-axis is represented with the red axis you can see over there, and the y-axis is represented with the green axis. So let's see how we can solve this moment of inertia with the whiteboard. While you were seeing this problem at a 3D scale, I decided to put details in this problem at this whiteboard. So x is the distance between the axis of rotation and dm, and dm is defined to be a small element of mass making up the rod. So the formula to get the moment of inertia is the integral of x to dm, but we need to substitute dm with the formula of linear mass density. Linear mass density equals mass times mass divided by length. We leave the m alone and then we put the differential in both sides, and we would get the differential of mass equals linear mass density times the differential of length. So we substitute it in here and we will get the integral of x to linear mass density times dx. We leave density apart and we integrate. So we would get linear mass density times x to the third power over 3 plus c, and we have the limits of 0 and 5. So we use the same process of definite integrals that we have used all the semester, and we would get this, and we will arrange it in this way to get a quicker answer. You would obtain this, linear mass density times 1/3 times 5 to the third power. But if you remember, linear mass density equals mass divided by length. So we substitute into this, and we have this times 1/3 times 5 to the third power. We substitute values, that is 0.2 kilograms divided by 5 meters times 1/3 times 5 to the third power, and we would get 1.66 kilograms times meter to the second power. And this would be your moment of inertia. So you will find problems like this in this major career because, as I mentioned before, mechanical engineering is about machines, and this topic is excellent for designing pieces of machines that have an axis of rotation, and you need to know the moment of inertia of it. Thank you for listening to my presentation, and here are the references. Bye!